All right, take a look here at this one. Example 7. We have our limit. We're going to find the limit here of this function f of x. We want to look at the limit as x approaches 2 from the left, the limit as x approaches 2 from the right, and the limit as x approaches just 2. Because remember, with our left and right limits, in order to have the limit as x approaches 2, it has to approach from the left and the right. Now look at what's going down right here. If I'm looking at this 2 in my denominator, underneath this radical, can I ever have a negative under the radical? No, right? So here's where your number sense comes in. So you have to have previous information coming into this current lesson. Look at what's going on. If I approach 2 from the left, that means I'm going to have smaller numbers than 2. So in essence, like 1.9. Could I put 1.9 in here? No, right? You see that? I can't, because if I put in 1.9, that's going to make this a negative number, and I can't have a negative under the radical. I can't use this one. Makes a negative under the radical. And if I can't approach from the left, then I can't have my full limit at all, because the only way you can have your full limit is if the left and the right agree. And this one does not exist. All right? Because my limit from the left does not exist, I cannot pull that off. Does that make sense? Okay. Okay, so the only thing I can do is take my limit as x approaches 2 from the right. So I'm going to scoot this down a little bit, and we'll make this happen, Captain. So my limit as x approaches 2 from the right, let me write this. X cubed minus 6x squared plus 8x all over the square root of x minus 2. Okay, if I'm approaching from the right, and I know if I just straight up plug that 2 in here, that's going to give me that 0 in the denominator. And that's my issue. All right? So if I know that putting that, just plugging it directly in gives me that 0 in the denominator, then I have to do work. But look at that numerator. Let's look at this numerator and let's do some factoring. I've got that whole square root of x minus 2. I can't really do a conjugate of that. I would just have to multiply it by that, and that looks like it's going to get a little crazy. But I've got this polynomial in the numerator, so let's see if we can factor and see if that helps us at all. So you can factor out an x, and you're left with x squared minus 6x plus 8 over, I'm going to write this as x minus 2 to the 1/2. Just because I don't know why, I just felt like it. We can still factor a little bit more out of that numerator, right? The limit as x approaches 2 from the right of x times x minus 4x minus 2. Hey, that works out nice. 1/2. The other reason why I was thinking, my head just does things quicker than other times. X minus 2, I'm figuring if I have to factor this and I want to try to cancel this out, I want to look at something that has an exponent so that I can work with those exponents like I have here. If this were still under the radical, then it's not as easy to work with. If I'm talking in terms of exponents with factoring, I want everything in terms of those exponents. Okay, well, check me out. This is x minus 2 to the first in the numerator, x minus 2 to the 1/2 in the bottom. Yep, if you have like bases, then you can subtract those exponents. This 1/2 takes that one down to the 1/2 in the numerator. Yeah. You see that? Like bases, you subtract those exponents. Hey, please note something else. Have I taken this limit yet? No. I'm just algebraing this down. So because I haven't taken that limit yet, I continue to write it. Once you plug that in, then we're good. And check out what just happened. I no longer have something in the denominator, so I no longer have an issue. We took care of the fact that I can't have a negative under the radical by taking it to the right from the beginning, so we're good there too. Now you just plug it in. So 2 times 2 minus 4, and then 2 minus 2 to the 1/2. That's all you need to know. Anything times 0 is 0. So we have a 0 here. All right. I'm going to squeeze this in. Let's look at this one more time. If I have this problem, I have something that can be factored. Even though I do have this radical, the moral of the story is you just have to approach each problem. Think about what you're given and then go with it. This is not a one-size-fits-all situation. When you work any kind of problem in math, the expectation now that you're in calculus is that, oh, guess what? You've had all this algebra. You've had all of this trig. Now you can apply it. So it's not going to be, ooh, this specific problem, you do this specific thing every single time. No. Look at it and use your algebra, right? Use that algebra. I say all the time, calculus is easy, right? Plugging this in, that's the easy part. The algebra that you have to do to pull that off, that's what you have to focus on. All right? Okay, you got this. And remember, keep that limit notation all the way until you plug it in. Once you plug it in, then you no longer have that limit notation because you performed that operation.